Recording has started.
Okay, so today we're going to continue with our reading scales and using measuring devices. And today we're going to look at meters. And I realize most of what you use now is a digital meter. And in the analytical setting, in the testing setting, that is going to be available to you most of the time. But if you're looking at some of your diagnostic machines, they still have dial meters on them just because they're quicker to read. You get into industrial quality control, putting a needle into a range is way quicker than trying to decide if a digital readout is in that range. So we're going to start out with a meter like this. The first thing you have to do with any meter or any scale is figure out what each division stands for. So on this one, we find two markings on the scale. So we've got the 10 and the 20 there. And we count between the 10 and the 20 how many spaces or how many divisions are there. Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces or 10 divisions between the 20 and the 10. Now this is, I'm just going to say this is a voltmeter so that we have units to put on those. So I had 10 volts to 20 volts. That's a range of 20 minus 10, or 10 volts. And that is divided by 10 divisions on the scale. So 10 volts divided by 10 means each division on that scale is 1 volt. Now that we know what each division stands for, then we can read, assuming of course that this is our needle, we can read that reading. So we find either above or below, whether you want to count down or up, it doesn't matter. Usually it's easier to count up. We find the nearest labeled marking to our needle. That would be right here, the 30. So 31, 2, 3, 4, 5. Often there's a halfway point that's easy to find like this one. So that's 35, 36, 37. So that's reading 37 volts. Many meters have multiple scales. One. So on this one here, somebody's got their microphone unmuted at home. If you want to make sure your microphones are muted. Thanks. So for this one, we have 3 different scales. We have a small scale, medium scale, and large scale on the same meter. We look at the switch down here, it's at the 16 volt setting. So that is the medium setting. We have the 8, 16, and 24. So that means we're going to be using this middle set of numbers because we're in the middle setting. We can double check the numbers and we can see that they are literally the set of numbers that's in between the others. So now again, we find 2 spots that are labeled. So this here is the 11 volt. This one's the 12 volt. So 12 volt minus 11 volt is 1 volt. And we count, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces between them again. So 1 volt divided by 10 means each of those spaces is 0.1 volt, or a tenth of a volt. So now we look up here. This is the nearest labeled marking from our needle. That's 12, 13, 14, 15, 12.1, 12.2, 12.3, 12.4, 12.5. Again, there's a halfway point we probably could have found. 12.6. So that is 12.6 volts. This meter here is an ohm meter. An ohm meter reads very differently from our other meters for a couple of things. One is it reads backwards. It reads right to left. It actually starts out with the needle at infinite resistance, and when we hook it up, it moves up to wherever the reading is. So the second thing that's different about our ohm meter is it's not a straight, what we call linear scale. This distance on this side of the scale is only 1 ohm. That same distance on this side of the scale is 10 ohms. If we moved even further, it would be 40 or 50 ohms. So the scale itself changes depending on the location within the scale. It's actually what is called a logarithmic scale. Where the larger the numbers get, the faster they increase. So to read one like this, we can't just find what each division stands for, because depending on where we're at on that meter, the division means something different. So what we have to do is we find the location of our needle. Of course, it's right here. And we find the nearest labeled marking on either side of it. So we've got 7 on one side and 10 on the other. And we can try to count up from one to the other. 7, 8, 9, 10. That appears to fit. So that needle is at the one that we counted as 8. So that's saying 8 on that scale. Now we do have a dial down here to account for. We always make sure we got to look and find those dials and deal with them if they have any meaning to the reading. That dial's on the times 1000. So that's saying that this is reading 8,000 ohms. Some meters have what's called an idler needle. What an idler needle does is it sits, you can turn it and set it yourself. Usually it's used to track, so if you have a reading at a current spot, you set that idler needle over the top of it. This one, we have the lighter dotted line as the old reading, so that's where the idler needle is set. If we look at that, that is pretty obviously reading at 41 volts. Well, let's double check it. This is 40 and 50, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces between there. So 10 volts, 10 spaces, that is 1 volt per space. So that's reading 41 volts. The new reading, where the regular meter needle has moved to, right here, well, that's 20 and 30. That halfway point is going to be the 25, 26, 27. So that is now at 27 volts. So the reason for using those idler needles, or tracking needles they're sometimes called, is so we can find the change. Well, from 41 volts to 27 volts, you take the new reading, 27, minus the old reading of 41. That's a change of negative 14 volts. It's dropped by 14 volts. Here's another ohm meter. Again, we have a dial to account for. This dial is times 1, so that doesn't change our meter reading at all. Up here, this is 1 and 2. These lines are really tough to read because they are so close together. But that's the 1 right there, and that's the 2. Definitely slightly closer to 1. I would say it looks like each of those are 0.2. This would be 1.2, 1.4, 1.6, 1.8, and 2.0. I would say that looks like is at the 1.4. The 1.4 ohms would be the reading I would give that. Now, the weakness of these analog meters over your digital meters. Your digital meters give you a number, There is no finding which line it's closest to. It just gives you a digital readout. The meter does any rounding for you. On these analog meters, we've talked about it with rulers and other devices, there is a built-in error because that needle can be slightly off or between lines on the scale. I want you to read this one in your notes. This is the old reading and the new reading. Read both of those and tell me what the change has been. So the old reading here is at 41 volts still, same as what we had on the last meter. This is 50, 1, 2, 3, 4, 5. That's at 55 volts. So we have new minus old, 55 volts, minus the 41 volts. This is a positive 14 volts. So this is going up by 14 volts. So this here is actually an exhaust analyzing meter from a test for an emissions test. So the first side here is measuring hydrocarbon output. We have to check. We see that this is on the low setting down here, so we're going to be using the small set of numbers. It's exactly between 200 and 300, so we're going to call that 250. On the carbon monoxide portion of the meter, we are again still on the low setting over here. So we're using the small set of numbers. Now, as we read this, we have to be careful. The decimal point here did not come through, but that's actually a 0.5. So this is 1.0, 1.5. That needle looks like that's hitting 20. It's actually 2.0. The needle's covering up the decimal point. So here we have an amp voltmeter. These actually used to be used quite a bit for electrical analysis in machinery and cars. First, we look at the amp side. On the amps, well, it's pretty easy to read. It's just pointing directly at the 200. On the volt side, we have 3 different settings: 10, 20, and 30. If it's on the 10 setting, we would read the bottom set of numbers. If it was on the 20 setting, we would read the top set of numbers. Notice this goes up to 10, this one goes up to 20. What if it were on the 30 setting? If it were on the 30 setting, we would actually read both sets of numbers and add them together. A little bit of an awkward way to get an extra degree of precision, but that's the way it works. Or the other option is you could read the 10 volt setting and multiply it by 3. That would work as well. So we are on the 20 volt setting, which means we're using this top set of numbers, which is really the easier set to read here. This is labeled as 8 and this is 10 with 1 division in between it. That means that middle number has to be 9. So that needle is pointing at 9 volts. This one here, I put the same meter up. It is the exact same meter we just read. I didn't put a different dial reading, but what I want to do here is let's read this as though the dial here is on the 10. So this is still 200 amps. That didn't change. So over here, if we're reading the bottom set of numbers, this is 5, this is 0. We have 1, 2, 3, 4, 5. It is between the 4 and the 5. It's right in the middle. Now here's one where we try We mentioned on our other measuring devices, we can't just guess in between markings on our scale. So here, depending on what school of thought you're working with, you might say either you have to call this 4 volts or 5 volts. But we do have the advantage here of having this other scale up here that is marked out with a marking in between. The 4 here, if the needle were on the 4, it would be exactly on the 8 up above. If the needle were on the 5 down below, it would be exactly on the 10 up above. Well, up above there is a 9. There is a marking in the middle, which is what the needle is on up above. Since it's in a middle marking on that scale, we can assume it's exactly in the middle on the other scale as well. So we're exactly between 4 and 5. That would be 4.5 volts. Now again, if you're not comfortable guessing between lines like that, that's understandable because I've warned you not to do it. This is one of those exceptions because there is a second numbered scale that does have markings in between. So here's another emissions tester. I want you to take a look at it for a minute, see what you read on it. We'll go over it in about 30 seconds. Okay, so on the hydrocarbon side of it, first we check our settings. We're on the low setting down here. So we're using the lower set of numbers. We are between 200 and 300, so that is at the 250. On the carbon monoxide setting over here, we are now on the high setting. So that means we're using the top set of numbers up here. We are pointing exactly at the 8. So we have 8 units of carbon monoxide being detected. In your notes, I'll let you read this one quick. We'll go over it in just a few seconds. So on the hydrocarbon side now, we are on the high setting. That means we're using the larger set of numbers up here. Now this scale's a little bit tricky to read. This is 1600 right here. The 2000 is actually this marking over here. So that means this middle one is actually 1800. So we're square between the 1600 and 1800. I am comfortable calling that in between at 1700. So there's 1700 units of hydrocarbons being produced in that exhaust. For carbon monoxide, we check our settings. We're on the low setting, so we're going to use the low scale. That's on the 2.0. Okay, so here we have 2 straightforward meters to read. Read each of those quick. We'll go over them in about 30 seconds. So for the top one here, we have 30 and 40. We've already counted out. We know that each of these divisions is 1 volt per division. So this is 30, 31. So that's just 31 volts for that top reading. Second one here, we know that this is 10 and 20. Might even go so far as to say that this middle line is 15, so we could count backwards if we wanted to 14. Or we could do 10, 11, 12, 13, 14. That is 14 volts. So this one here, again, we've got to find the appropriate setting. We're on the 8 volt setting, which is the smaller scale, which means we're reading these top numbers up here. To figure out what those divisions are, this is 6 volts here and 7 here. 7 volts minus 6 volts, of course, is a range of 1 volt. If we count, we have 1, 2, 3, 4, 5. Then I know that each of these other sections are the same, so that'd be 5, 10, 15, 20 spaces between the 6 and 7 volts. So that's a 1 volt span divided up into 20 divisions. That's 0.05 volts per division. So now this is at 7 right here. That next marking would be 7.05. That's saying 7.05 volts. In your notes, I want you to take a minute and read this one. So this is on the 24 setting, so we're reading the larger scale here. We've got 22 and 24 labeled. 24 minus 22 is 2 volts. In between there, we have 5, 10 markings. So 2 volts divided by 10 means each division is 0.2 volts. So this is 22, 22.2, 22.4, 22.6 volts. This one here is on a different setting. Take a minute and read that one in your notes. So it's on the 16 setting, which means we're using the middle set of numbers here. So we've got 12 and 14, which is 1 volt. Or sorry, 13 and 14, I should say. 14 minus 13 is a 1 volt range. Between there, we've got 5, 10 divisions. So 1 volt divided by 10 means each division is 0.1 volts. Now at this point, we've read this particular meter at every setting, so we know what each setting represents, what each space represents on each setting. So this is 13, 13.1, 13.2, 13.3, 13.4. It makes sense that middle line should be 13.5, so 13.4 volts is where we're sitting. So then this one, we are on the 16 volt, the middle setting again. So this is 13 and 14. This is 13.5, 0.6, 0.7, 0.8. So that is 13.8 volts is the reading on that one. Now these next several are what we call surface gauges. These are used to judge irregularities in a surface. If you're at a machine shop planing a head for a motor or planing the top of a block for a motor, this would be used to measure how consistent that surface is, how flat that surface is. So these gauges start out at 0, and they can actually go either direction. They can read negative below surface or positive above surface. So the first thing, of course, this is a millimeter one. It says 0.01 millimeters. The first thing we have to read on these is whether it's positive or negative. The arrow here tells us the needle has moved that direction from 0, so this is positive. Second thing we have to read is how many complete revolutions this has made. This little dial down here tells us that. It is between the 0 and 1, which tells us it has made 0 complete revolutions. On the millimeter gauge like this, that number is what goes in front of the decimal point from the small dial. So that is 0 point, is what that's telling us. 0 whole millimeters. Then we read the dial. This is 10, 11, 12, 13, 14, 15, 16, 17. So that is a positive 0.17 millimeters. So this reading right now is 17 hundredths of a millimeter above the reference point of the surface. So for this one, we start out, we see it's reading in the negative direction. So it's going to be negative. We go down here to the dial. The little dial, it's between 2 and 3. So that's going to be 2 that we use. It's more than 2 revolutions, less than 3, so it's 2.0. Now, reading the big dial, we have to account for the fact that we've gone in this direction. Notice that in both directions, it starts out 10, 20, 30, 40. 10, 20, 30, 40. So the way we read the big dial depends on the direction we're going. We've gone this way, so we read 10, 20, 30, 40, 50. This is actually 60, 70, 80, 81. So that's a negative 2.81 millimeters is what that meter is reading.
How do you know that it went to negative? Because it's pointed off to the right, so wouldn't you think that was positive?
Because it has this 0 here, that tells us that when we were watching the gauge and the needle started to move, the needle wrapped around in this direction.
Oh, okay.
That's the only way we know off of these pictures, is there's that little arrow there. See, this one has the arrow there. This one's negative as well. This one's positive.
I got you. Thank you.
You bet. Yeah, without actually watching the meter move, there's no way to tell other than having that arrow there. But normally, yeah, very good question, Dennis. You'd be watching the meter, and you would see whether the needle moved to the positive side or the negative side. So this one's going to the negative side again. Negative, we go down here, it's between 0 and 1. So it's 0 whole revolutions. This is 10, 20, 30, looks like 29. So negative 0.29 millimeters is the deviation from our reference surface there. This one is the arrow is showing positive. It's between 1 and 2 down here, so that's 1 point whatever in our reading, 1 whole millimeter. And now we're reading this way, so 10, 20, 30, 40, 50, 60, 70, 71, 2, 3, 4. So that's 1.74 millimeters positive. I'll give you a minute to look at this. Oh, sorry, this one is different. This one is in inches. You can see it's 0.001 inches, or thousandths of an inch. You can also see the little dial here has decimal points in front of each number. So that means that that little dial is the tenths of an inch. So the arrow is showing us that we went positive again, so this is positive. Down here we're between 0.1 and 0.2, so that's 0.1, so 1/10 of an inch. And this is at 10 again, so we put another 10 thousandths there. So this is a positive 0.110 inches that gauge has moved. This one is still in thousandths of an inch. The arrow indicates that the needle has moved in the negative direction. So that's negative. This is on 0.9, but it is not quite it's gone all the way around to there and not quite back to 0, which means we have not quite made it to 0.9 yet. We're still between 0.8 and 0.9. That's a negative 0.8. That's a very tricky one to read because that needle looks like it is smack on the 0.9, but is not quite to it yet. And then, of course, this is 10, 20, 30, 40, 50, 60, 70, 71, 2, 3, 4, 5, 6, 7, 8. So 78. That is a negative 0.878 inches is what that is reading. So this one is positive. It is, looks like it's past the 0.4, and that registers here. We've passed 0 here. So we've passed the 0.4, so it's positive 0.4. 30, 31, 32, 33, 34, 35, 36, 37. So it's a positive 0.437 inches is that reading. I'll give you a minute to read this one in your notes. We'll go over it in about half a minute. So this one starts out, the arrow is telling us it's going negative. Down here, we're between the 0.1 and the 0.2, so that's 0.1 inches. 10, 20, 30, 40, 50, not to the 60 yet. That looks like 59. 1, 2, 3, 4, 5, 6, 7, 8, 9. It is. So that's a negative 0.159 inches is that reading. Let's look at some other meters here. We have a vacuum meter. Used to be used for measuring automatic transmissions for shifting when we actually still had vacuum shift in a transmission. Now they're a mechanical shift, or hydraulic shift. So this one here, we have 2.0 and 2.5. 2.5 minus 2.0 is 0.5. And there's 1, 2, 3, 4, 5 divisions between there. So each division is 0.1. So that's 2.0, 2.1, 2.2 units is what we're at there. This one here, we have 0 and 50. That's 50 volts range. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divisions in between. So that means each division, 50 divided by 10, is 5 volts. Now I can find that this middle one is 25 volts. That helps. That's halfway between 0 and 50. That helps speed up the reading a little bit. So that'd be 25, 30, 35, 40. 40 volts would be that reading. So here we're looking at an alternating current. This is measuring still voltage. We have 6 and 8, which is 2 volt range. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. 2 volts divided by 10 space. This means each space is 0.2 volts. So this is 6, 6.2, 6.4. Here's another variation of our ohm meter, a logarithmic scale, where we are moving right to left. We're going backwards, and of course the scale changes as we move up. This is 10 and 15. Here's our needle is between the 10 and 15. And it looks like we can just count out 10, 11, 12, 13, 14, 15. That works out. So we are on a 12 ohm reading here. There's no other dials or any settings down here to be a multiplier for this one. I'll have you read this one quick in your notes, see what you come up with. So this is saying that's 100 ohms, and this is 150 ohms there. So I'd say 110, 120, 130, 140. That's either 120 or 130 ohms. Either one would be acceptable there. Those lines are close enough together that we really can't be exactly sure which one it's on. This one here, I'm just going to read it for you. This is the 500. This is 1,000. It appears that the needle is right on the 1,000 and 1K. So 1,000 ohms or 1 kilo ohm is what that's reading. This one's a little easier to read. I'll give you a minute to read it. That's the 5 and 10. Now, if we tried to just count up 5, 6, 7, 8, 9, 10, that doesn't work. So we look at this and we realize that there's half marks here. This would be 6, 7, 8, 9, and 10. So what we're on there is actually 5.5. We're halfway between the 5 and the 6. This one's pretty straightforward. I'll give you a second to read it. So 100, 150, that would make this 125. It looks like each of those is 5, this would be volts, 5 volts. So that's reading 120 volts right now. And now these last two, the depth meters, want to make sure you have plenty of practice with these. So I'm going to have you read this one in your notes. We'll go over it in a minute. So this one is reading in inches. This is, first of all, telling us that we start off in the negative direction. Dials between 0 and 1, so that's 0.0. 10, 20, 30, 40, 50, 1, 2, 3, 4, 5, 6. So negative 0.056 inches. Then I'll have you read this one. We'll go over it in a minute. So this is in millimeters. This is going in the negative direction. We're between 2 and 3, so that's actually whole millimeters. For the millimeters, the little dials in front of the decimal point. And then we're going this way, so it's 10, 20, 30, 40, 50, 1, 2, 3, 4, 5, 6, 7, 8, 58. So negative 2.58 millimeters. So for homework, you have in your book page 209, problems 1 through 41, the odds, reading different meters and those surface gauges. Again, tomorrow morning I won't be here. I'll be gone for an appointment, so there won't be math class tomorrow morning, so I won't see you all until Tuesday now. If you want to use the last 11 minutes here to start on the homework, you may. I'll be around to answer some questions.